Hello, everyone, and welcome to our presentation on data integration. Today, we'll explore what data integration is and why it's crucial for data science projects. So, what is data integration? Think of it as the process of combining data from various sources into a unified format, much like merging puzzle pieces to form a complete picture. By integrating data, we enable data scientists to gain a holistic view, uncover hidden patterns, and build more robust models. Let's dive into the benefits of data integration. First, it improves data quality. By integrating data from multiple sources, we can identify and rectify inconsistencies, ensuring the data we work with is accurate and reliable. Next, it streamlines data access and manipulation. With a centralized data hub, accessing and working with data becomes easier and more efficient. Data integration also enhances collaboration. A unified data platform fosters collaboration among data scientists, allowing them to work together seamlessly. Finally, it provides a holistic view of the data. By breaking down data silos, we can uncover hidden patterns and relationships that would otherwise go unnoticed. Of course, data integration comes with its own set of challenges. Data heterogeneity and complexity require careful cleaning, standardization, and mapping of data. This can be a time-consuming and meticulous process. Scalability and performance issues are another challenge. As data volumes grow, we need scalable data integration tools to handle the increased load efficiently. We must also consider data security and privacy concerns. It's essential to balance comprehensive analysis with robust data security and privacy practices. To overcome these challenges, let's look at some best practices for data integration. First, define clear data integration goals and requirements. Understand what specific data is needed and for what purpose. Next, choose the right data integration tools and techniques. Depending on data volume and complexity, you might opt for ETL extract, transform, load, or ELT extract, load, transform. Conduct data quality checks and cleansing to ensure the integrated data is accurate and reliable. Consider data security and governance. Establish data governance policies to control access, ensure compliance, and maintain an audit trail. Lastly, monitor and maintain the data integration process. Regularly track data quality metrics, monitor pipelines, and schedule data refreshes to keep your data up to date. Now let's walk through the data integration project lifecycle. It begins with planning and requirements gathering. Define project goals, identify data sources, and assess data quality. Next is design and architecture. Choose the integration approach, design the transformation process, and select the appropriate tools and technologies. Development and implementation come next. Develop data extraction pipelines, implement data transformation logic, and build the integration platform. Testing and validation are critical steps. Test data integration functionality to ensure accurate data extraction, transformation, and loading. Validate data quality to verify that the transformed data meets the required standards. Conduct performance testing to assess data processing speed and efficiency. After testing, it's time for deployment and monitoring. Deploy the integration solution into your data science environment. Lastly, implement data governance policies. Establish security measures, access controls, and versioning to maintain data integrity. In conclusion, by following these highlights and understanding the data integration process, data scientists can ensure a smooth and successful data integration project. This leads to a well-integrated data foundation for building robust data science models and deriving valuable insights. Thank you for joining us today. We hope this presentation has provided you with a comprehensive understanding of data integration and its significance in data science. Let's continue to explore and master these essential skills together through Mastery in Data Science program.